Welcome to AskeyGeek.
Hey, if we haven't met already, I'm the digital avatar of AskeyGeek,
where we build your next advantage with tomorrow's technology. And today, one of our experts is stepping in to show our latest breakthrough. Enjoy and happy learning.
All right. For most professionals, a 290-page PDF is a dead end. It's a monolithic block of information that creates an administrative lag, the days or weeks spent just trying to parse what's actually important. This line represents your knowledge retention after reading. It plummets almost immediately because passive consumption is the least efficient way for the human brain to store new data. If the problem is that static text doesn't stick, the solution is a system that actively challenges you with that text. This is why we build a virtual dean, a proxy agent designed to manage your interaction with the data. Our goal is to engineer an AI employee that fractures a dense textbook and reassembles it into an interactive learning ecosystem in under a minute. To move past the passive trap, we have to stop reading for volume and start building systems for retention. We built this using the DBS framework: direction, blueprints, and solutions. We start with the direction layer. This is handled by the curriculumbuilder.md file. This markdown document acts as the manager, providing the AI with a non-negotiable set of workflow rules and logic. The first instruction involves scanning the raw text to isolate threshold concepts. These are the critical nodes of information that, once understood, allow the rest of the subject to click into place. By defining this logic in a dedicated file, we ensure the AI operates as a targeted extraction engine rather than a general-purpose chatbot. The B in our framework stands for blueprints. These are the reference files that provide the system with its specific pedagogical context. Instead of letting the AI guess how to teach, the blueprint explicitly forbids rote memorization and simple word matching exercises. This upward trending line shows how we fix the retention problem. The blueprint enforces active recall and spaced repetition, repeatedly correcting the forgetting curve. The AI uses these rules to reframe threshold concepts into scenarios that force you to prove why and how it works. The blueprint ensures the AI acts as an elite educator, focusing exclusively on high-retention learning strategies. Finally, we reach S for solutions. This is the executable layer where the AI triggers specific tools and code. Claude uses Python scripts to perform tasks that natural language can't handle alone, such as generating formatted files or building interactive interfaces. The first output is a structured .enky flashcard deck, formatted automatically so you can immediately begin your first review session. Simultaneously, the system generates a fully coded interactive Claude Artifact, a custom quiz application that provides instant feedback on your progress. Through the DBS framework, a static PDF is reconstructed into an actionable suite of learning tools. By the time you finish this process, you haven't just read the document, you've been tested by it. Every minute spent in the system is now spent solving problems rather than just moving your eyes across a page. If a human educator were to manually extract these concepts, draft the questions, and code the software, it would represent dozens of hours of labor. This chart shows the return on that investment. You are replacing weeks of manual curriculum design with seconds of local AI processing. Mastering content atomization means that you are no longer limited by the speed at which you can read, but by the speed at which you can interact and respond. Automating the extraction of information is about ensuring that the time you do spend studying is actually reflected in your long-term memory.
All right, that's the update from the lab for today. I hope you learned something new. Head over to AskeyGeek.com.